Let's start today's class with Kirchhoff's laws. Kirchhoff's laws are very basic laws, and they are actually based on the conservation of charge principle and the property of electric fields that we have already studied. These are only the application of those. First law says current law. It says that at any junction, total current that enters should be equal to the total current that leaves. Junction here, it's not that if you connect two conductors at a point, this is a junction. At least three conductors should meet at a point, then this point can be treated as a junction or node, right? So node is a point where more than two conductors will meet. So suppose this is a node that I have taken here. You can see that at this node there are five conductors, they are meeting. And if I assume the currents to be I1, I2, I3, I4, I5 respectively, then you can see that the currents they are entering to that node are only I1 and I2, and current they are leaving from the node is I3, I4, I5. So according to this, Kirchhoff's law says that the total current enters should be the total current that leave from that junction, particular point node. So I1 plus I2 equal to I3 plus I4 plus I5. Right. So that is a very common rule, and this is a basic rule. Can you tell me that which principle actually is used here?
Conservation of charge.
Yes, conservation of charge. Conservation of charge. That if somehow 100 coulomb charges are entering at that point, then 100 coulomb charge should also leave from that point. Otherwise, this point will be a source or sink of charge. That is not possible here, right?
Sir, কত স্টার্ট হয়েছে?
Hey, just start column. First line, just start column. So this is the first law of Kirchhoff's, which is also known as KCL, Kirchhoff's current law, and another law is there which is known as KVL, Kirchhoff's voltage law. Voltage law also a very simple law. It says in any closed loop the total voltage drop is zero. So if there is a circuit which forms a closed loop, every electrical circuit you will find that they will form a closed loop. If they are not a part of the circuit, if they are a part of a circuit, then you may not have a closed loop. But if this is a complete circuit, definitely there will be a closed loop, right? Without a loop, current cannot flow. Current cannot flow in arbitrary conductor where one end is free, right? One end should connect with the other end by some method, by some electrical equipments or battery. Somehow they should be connected. So in a closed loop, it says that the total voltage drop is zero. Can you tell me which principle here you have used to say that law?
Conservation of energy.
Conservation of energy. No, energy is not conserved here at all. Why energy is not conserved? Because in resistance,
electric field is conservative force.
Yes. That formula we have studied, you should know that integral of E dot dl equal to 0 in a closed loop. Do you remember that?
Yes, sir.
Integral of E dot dl equal to 0 in a closed loop. What is E dot dl? E dot dl is nothing but dv, if you remember. Yes, so integral of E dot dl in a closed loop. I hope that you remember that. Integral of E dot dl is equal to 0. That formula is used only here. Right, in a closed loop, the total potential drop, that you can also say the delta V. So delta V in a closed loop is always 0, but loop should be closed, right?
So potential drop 0 হলে current কিভাবে flow করবে?
Net potential drop is 0. That means if somewhere potential is decreasing, definitely somewhere the potential should increase.
আচ্ছা,
right? So in resistance the potential will decrease, but battery will again increase that potential. So that is why the net drop is 0. Let us take one example for that voltage law, because that law we will use very frequently. Both the laws are very much useful here in this chapter. Let us assume that this is an electrical circuit consisting 3 resistors and 2 batteries. I have shown the connection, this battery V1 and this battery is V2. The resistors are also shown. Now look, how do I get the equation for this loop? So there are 2 loops, as you can see. I have marked them 1 and 2, right? So in that loop, I have a circulated current, and in that loop, I have also circulated the current. And you have to always assume the value of the currents, and in any arbitrary direction, you can assume that value. It is not mandatory that you have to assume this value in counterclockwise sense. You can assume the value to be clockwise sense also. If we find the value of current is negative, you have to understand that the direction of flow that you have assumed it was not correct, right? Current is flowing in opposite direction. So just like this, I have assumed that this R1 is carrying I1 current from right to left, and this resistance R3 will carry I1 minus I2. Why I1 minus I2? You can see that this current, this R2 resistance is carrying current I2. Now at this point, if you look about this junction, can you say this is a junction? This junction I have used the KCL, current conservation law, right? At this point, the current is entering is I2 and leaving is I1, right? So definitely another current should enter at that point, so that the two current I1 plus I2 plus I1 minus I2 is equal to I1, right? So that is why the current in R3, you can always assume it to be I3, but it is always better not to increase the number of unknown. So that is why I have written this current in terms of I1 and I2 only. Now we have two loops, and how do I write down the loop equations? Remember always that whenever you are flowing in the direction of current in a resistance, the potential will always decrease, right? Again, I'm saying that just try to take a note that whenever we move along the direction of current in a resistance, potential will decrease, and whenever we will move along the opposite direction of current in a resistance, the potential will increase. That only comes from the very basic Ohm's law. Ohm's law says that if there is a resistance and current flows in the direction of in any direction, suppose there is a resistance and current flows in this direction, then what is the potential? Potential will increase or decrease along the direction of current. What you can say? Decrease, right? Potential will decrease. So change in potential is equal to negative in this direction if you move, and if you move in opposite direction, because current always flows from higher potential to lower potential, remember that. So this is the higher potential, and this is the lower potential, right? This is the lower potential. So current always flows from higher potential to lower potential. So that is why delta V is negative along the direction of current. In opposite direction, you will take it positive. Now, in order to write a loop equation, or voltage equation, you have to flow in a particular sense, right? Whatever may be the direction of current. Suppose here you have taken the direction of current to be anti-clockwise, but it is not mandatory that when writing your equation you always flow anti-clockwise. You can also flow clockwise, but it should be always clockwise, right? For example, if I try to write down this loop equation starting from this point, any point you can starting from this point. So from this point to this point, if I write down the voltage difference, what should I write? From this to minus I1 R1, right? Minus I1 R1. Then from this point to this point, look, the battery potential is increasing because I am going from lower potential to higher potential. So plus or minus V1 plus V1, right?
Plus V.
Yes. Now here to here there is no potential drop. Now from here to here again I will write potential drop. So that will be a drop or increase. If I am going along R3 along this line, a drop. Right. So that is minus of I1 minus I2 R3. And that the entire net potential drop in this circuit will be 0. So that is a one loop equation. And similarly, you will write another loop equation, and you will find two equations where the unknowns are also 2, I1 and I2. And you can solve them to find your answer.
Minus I2 R2 plus
minus I2 R2?
I2 R3 minus 2.
Yes.
Plus I1 I2 R3
yes.
minus V2.
Minus V2 equal to 0. Good. Look, again I have moved from this point, anti-clockwise direction. So minus I2 R2, but here in case of R3, I am moving opposite to the direction of current, right? Opposite to the direction of current, right? So that is why I have got plus of I1 minus I2 into R3. Opposite to the direction of current, or always potential will increase. And then from plus to minus, it's a negative decrease of potential. I have taken negative sign. I hope you have understood how to use that KCL and KVL in circuits to solve the equations. I have also written the loop equations for your reference.
Sir, in second loop,
Yes.
current always flows from higher potential to lower potential.
Yes.
So, sir, I1 minus I2 is in the same direction, from higher potential, because it is from the positive end of the battery. So it will be.
What you
like
have assumed?
negative.
What you have assumed? The potentials you have assumed or currents you have assumed? I have assumed currents, not potential. When I have assumed currents, automatically you have assumed that this is higher potential, this is lower potential. Right?
Okay.
So when you are coming from here to here, actually you are increasing the potential, because the lower potential to higher potential you are jumping. The part of the circuit, right? This is a part of a circuit. Can you find the potential of the point B?
এটা কি গ্রাউন্ড করা আছে?
Yes. Look, what we can say about that circuit first. If this current is 3 ampere, this current is 2 ampere, can I say the current in this branch is 1 ampere?
Yes, sir. Yes, sir.
Yes. Now let me start from this point A. Right? From this point A, this current is 3 ampere. So if this is 3 ampere, then what is the potential of this point after the resistance here?
Minus 6 volt. Minus 6
This is 0, right?
Sir, answer will be 5 volt.
Let me calculate first. So it is 0 minus 3 into 2 is 6. Now I am jumping from higher to lower, so that will be another minus 10. Now again I am jumping
So
from
minus 18.
From here to here, so it is minus 3 into 1. Then I am going from here to here, but the current is 1, so it is minus 4. Then I am jumping from here to here, which is a plus 6. Then from here to here, which is a minus 1. That should be the potential of B.
Yes.
Plus 6 minus 6 gets cancelled out. So it is 10 and 3 13, 4 17 and 1 18. So that is minus 18 volt. Now that is a electrical circuit. Find the current in all the branches. Actually, you have to find the current. Let us assume current in this branch is in this direction I1. In this branch is I2. And this branch is I3.
স্যার
বলো
5 ওহম দিয়ে 2 অ্যাম্পিয়ার
ঠিক
আর 1 ওহম দিয়ে 16 অ্যাম্পিয়ার
হুম
As I to the 3, 8 by 3 ohm, 8 by 10 ampere.
দেখো আগে, can you see that this 5 ohm circuit, it is independent.
Yes, sir.
If you only draw this equation for that 5 ohm, you will definitely find that the potential drop across this 5 ohm branch is only 10. Can you see that? Potential drop across this 5 ohm branch is only 10. So what is the current in that 5 ohm branch is definitely 2 ampere. You don't have to calculate anything for that. Right? Now come to this circuit. And 2 ohm and 2 ohm, they are in series. So you can definitely write this as 4 ohm and that is your 2 volt battery. This is 6 volt battery.
ব্যাটারিটা তো হোম দুটো মাঝখানে আছে।
থাক না, কোনো অসুবিধা নেই। কারেন্ট তো দুটোতে একই যাবে। Current in the circuit will be the same. Battery does not matter. Current will be the same in a branch.
স্যার
বলো
ওই যে 5 ওহম আর যেটা লেগে আছে, মানে ওই একটা পয়েন্ট তিনটে লেগে থাকবে, মানে কারেন্টটা তো ওই জায়গাটা তো आगे হচ্ছে আলাদা আলাদা
The
করে না?
potentials are same at this point and this point. Potentials are same. You can always add those.
আচ্ছা স্যার ঠিক আছে
Right? No problem. Now you can see that if I try a equation for this branch, if this current is I2, I have assumed, then what is the equation for KVL in this branch? If I go in that anti-clockwise direction, then I can say I2 into 1, I2 into 1, that is minus from here to here. Then from here to here it is plus 10, right? Because I am going opposite to the current. And then from here to here it is plus 6 equal to 0. So I can directly find that what is I2 is equal to 16 ampere. Right? Easy to find what is I2 is 16 ampere. So this current is 16 ampere. And now you can do another loop equation here where I have assumed this current to be, in opposite direction I have assumed the current, no problem. Suppose in that direction I have assumed the current to be I1. So if I move from here to here, so it is minus 4I1. From here to here it will be plus 2, and then from here to here it will be plus 6 equal to 0. So 4I1 is equal to 8, I1 is equal to 2. Right? I1 2,
Yes, sir.
I2 16. What will be the value of I3? Can anyone tell me what is the value of I3?
20.
Yes?
20.
20.
Sir, 8.
Look, if this is 16 ampere, this is 2 ampere, then this current must be 18 ampere, yes or no?
Yes.
If this current is 18 ampere, this current is 2 ampere, this current is in this direction, this current is 2 ampere, so that current must be 18 ampere. This is 2, this is 2, so they will cancel out because this is entering, this is leaving. So whatever leaving in that branch, that should enter in that at that point. So current from the 10 ohm branch, 10 volt battery is not 2 ampere, right? Remember, 2 ampere is the current in 5 ohm branch, right? But the current in 10 volt battery is 18 ampere. I3 is equal to 18 ampere. The same question can be attempted in this way also. This is called a nodal analysis method. Nodal analysis method. In nodal analysis method, remember what I am saying. You can assume potential at any one point to be 0. Any one point. You cannot assume potential of multiple points to be 0. You can assume potential at any one point to be 0. And if in your circuit somehow a point is grounded or earth, then you have to assume the potential at that point definitely 0. Understood? So in this case, if I assume the potential of this point is 0, what is potential of this point?
10
10.
10 10
Now look, if this potential is 10, this potential is 10, that potential will also be 10.
Yes.
Yes. And if it is 10, then what is potential of this point?
16
Plus 6. Plus 6 because I am adding potential, so it is plus 16. And if this is 0, then that potential is also 0. Now can you see the potential drop across this 1 ohm resistor is 16 volt?
Yes, sir. Yes, sir.
So what will be the current in that
Yes,
1
sir.
ohm resistor? Definitely it will be 16 ampere. Right? Now if it is 10 volt, right? If it is 10 volt, you can now go look to that circuit. If this is 10 volt, what is the potential of this volt? This potential? If this is 10, this is 0, this is 16. What is potential here?
8.
8. Now this is 8 and this is 16. So what is the potential drop between these 2 points?
8
8 divided by the resistance 4. So what will be this current? 2 ampere. Right. Now you can understand that all the values we can find without any calculation. We can do it just by writing the potentials. Find the current through 25 volt battery. By nodal analysis method we will solve it. Let us assume this potential is 0. What is potential of this point now? 25 volt.
Yes, sir.
Now can you see that all these lower potentials are 0?
Yes, sir.
So if this is 25 volt, all these upper potentials are 25 volt. If this is 25, what is potential of this point? 55. 25 plus 30, because potential I will increase. So if this is 55, this is 0, then what is the current in that branch? 5 ampere. This is 25. Now I will decrease that by 20 volt. So what is potential at this point? 5 volt. So what is current at this point?
1 ampere.
1 ampere. This is 25, this is 5. So now I will increase or decrease here?
Increase.
Increase.
30.
So this is
30.
30 volt, right? So 30
3 ampere.
means this is 3 ampere. And this is 25, this is, I will decrease or increase?
15.
Decrease. This is 15 volt. So that will be 3 ampere. 3 plus 3 plus 1 plus 5 is 12 ampere. That is the answer of this question. Now there is a question, if all the resistors are 1 ohm and current in the lightmost resistance, that means, let me draw this current. This current is 1 ampere. Then what is the battery voltage? What is the value of V that you have to find in this question? Suppose this branch is carrying current 1 ampere. It says that all the resistors are 1 ohm. Yes?
41.
Yes, 41 volt is the correct answer.
ভুল করে একটু 45 লিখে দিয়েছিলাম আমার চ্যানেলে।
Yes. Look, this branch, this resistance is carrying 1 ampere current. So what will be the current in all these two resistors? 1 ampere,
1 ampere.
right? So if this entire branch is carrying 1 ampere current, can you just tell me what is the potential difference between these 2 points A and B? 3 volt, yes or no?
Yes.
Because the 3 ohm resistance carrying current 1 ampere, so the potential difference between these 2 points is 3 volt. Now if the potential difference between these 2 points is 3 volt, then what is the current carried by this resistance? 3 ampere.
Yes.
Now by application of the KCL, can you tell me what is the current in this branch?
4 ampere.
4 ampere.
4 ampere. Similarly, current in that branch will also be 4 ampere. 3 plus
Yes.
1, 3 plus 1, 4. Do you follow this? Now if this point is C and this point is D, can you tell me what is the, yes,
স্যার আবার একটু রিপিট করুন 3 অ্যাম্পিয়ার কি করে এলো ওখান থেকে?
how we have got 3 ampere? If the potential, if you see this circuit between A and B, this is 3 ohm resistor, the current is 1 ampere. What is potential drop between A and B? Tell me what is potential drop between A and B?
3 ভোল্ট।
3 volt. So if there is another resistance I have connected here which is 1 ohm, then what will be the current in that branch?
3 অ্যাম্পিয়ার।
3 ampere. Similarly, if I now ask you what is the current in this branch, what will be the current in this branch? It will be 3 plus 1, 4. Yes or no? Now if this branch is carrying 4 ampere current, then what is the potential between C and A? What is potential drop between C and A?
11 volt.
Between C and A, it is 4 volt.
4 volt.
Between A and B, it is 3 volt.
3 volt.
And between B and D, what is potential drop? Again 4 volt.
4 volt.
So what is potential drop between C and D?
11 volt. 11 volt.
11 volts. So what is current in this branch?
11
ampere.
11 ampere. Then what is current in this branch?
15 ampere.
15 ampere. Current in this branch?
15 ampere.
15 ampere. Then what is potential drop? Suppose this is PQ. What is potential drop between P and C? 15 volt. What is potential drop between D and Q? 15 volt. What is potential drop between C and D? 11 volt. So what is potential drop between P and Q?
40 ohm.
41 volt. That should be the answer of this question. This is also a very good question. Right? Try to solve it. Very simple looking question, but it came in one of the Olympiads. Right? But I think that you will be able to solve it. If I say that when I will add this R4 with this circuit, then the equivalent resistance of that circuit, it will increase or decrease. Can you tell me? Decrease. Because when you add something in parallel, then remember that the equivalent resistance will be lower than the lowest one. So whatever may be the lowest of between R2 and R4, the equivalent resistance will be lower than that. Right? So definitely the equivalent resistance of this branch will decrease and the current in R1 will increase. That is a very basic thing, and I think that you have understood what is the answer for the first question, that the current will increase. Now let us move to the second one. Let us assume that current in this branch is I1, current in this branch is I2, current in this branch is I3, and current in this branch will be how much? I1. The potential is V. Can I write a loop equation in this branch? What loop equation I can write? And let us also assume that the value of the resistors are 4, 1 and 2. Right? You can assume 4k, 1k, 2k, anything. But let us assume k to be 1. The answer will not change. 4, 1 and 2. So if I write down one equation, can I write V minus 4I1 minus 1 into R2, 1 into I2 minus 1 into I2 minus 2I1 equal to 0. Can I write down this equation?
Yes, sir.
So can I write this expression that 6I1 plus I2 equal to voltage V?
Yes, sir.
Now look, from here we can say that this, if I differentiate this function, can I say 6 delta I1 plus delta I2 is equal to delta V, which is 0, because the battery voltage is not changing.
Yes, sir.
And what is delta I1? Can you tell me from this question?
0.2.
Plus 0.2, because if I add this, then current will increase in R1. So what is delta I2? Is that minus 1.2?
Yes, sir.
delta I2 is minus 1.2. Have you got this one?
Yes, sir. Yes,
Now,
sir.
if I apply KCL, can I say I1 equal to I2 plus I3? Yes or
Yes,
no?
sir.
So what is I3 is equal to I1 minus I2. If I further differentiate this expression, can I say delta I3 is equal to delta I1 minus of delta I2?
Yes, sir.
What is delta I1
0.2
and what is minus of delta I2?
plus 1.2.
Can I say that is only the answer of this question, because initially I1, I3 was 0 and delta I3 is the change of I3. So what is the change of I3 will be the final value of I3. Right? Differential form,
ডিফারেন্সিয়েশন করে যান
differential at any respect. You can differentiate it with respect to time, with respect to some another I1 with respect to I2, anything. Ultimately you will find the same thing because delta V is not changing, so finally it will become 0. Differential forms of KVL and KCL are also valid, right? So I think we have done a lot of calculations with that Kirchhoff's laws. Now let us come to some another. Okay, that is also a good question, but I will not solve it today. I'll give that question as your homework, right? Try this at your home. Now we will talk about electrical circuits and their symmetry. There are two types of symmetry that you will find in any electrical circuit, right? If there are symmetry, if they are symmetrical circuit, in most of the case you will find that the circuits are symmetrical, right? So what type of symmetrical circuit you will find? Look, this is one type of symmetrical circuit. Can you see that in that circuit, if I have connected battery in between these 2 points A and B, symmetry always refers to a mirror image. So can you see that if I draw a line like this line actually bisects the line joining the source A and B, right? This line is a perpendicular bisector of the line joining the source A and B. Can you see that the left portion and right portion of this line are nothing but mirror image to each other?
Yes, sir.
Yes.
Yes, sir.
So one thing you can definitely say, that if this branch is carrying current X, then this image branch will definitely carry the same current X, right? Because you cannot put any bias between these two branches. They are absolutely symmetrical. Similarly, if I say that this branch is carrying current Y, then this branch will also carry the same current Y. Now from this, what you can conclude actually, look, the branch that is connected between the upper and this lower branches, the intermediate branch, this one I am talking about, this one. Can you see that this branch will carry zero current, because whatever was the current X that will flow here, whatever will be the current Y that will flow here, just like they are in series, just like these two branches are in series. So what is the role of this middle branch that is connecting these two junctions? Definitely zero. The current will be zero in that branch, right? So this type of symmetrical circuit, whenever you will find, you can eliminate this resistance which actually is joining, or you can directly say that the current in the image branches will remain the same. This type of symmetry, I call it is a vertical symmetry, because this line is vertical, so I call it a vertical symmetric line, and it is symmetric about the bisector of line joining the source, right? This line. And what is the speciality? Whenever you will see that vertical symmetry in a circuit, you need to understand that current in the image branches are always same, right? So now if I ask you to only find out the equivalent resistance between the point A and B in that circuit, if all the resistance between any two nodes is R, what will be your answer?
2R/3.
How we can say that? If this is R, this is R, then this is 2R. Right? And now we can find what is the equivalent resistance. Actual circuit is this one.
So it will be R/2.
Now can you see that this resistance I can neglect? So if this is R, this is R, this will be 2R, this will be R, this will be R, this will be 2R. So 2R and 2R are in parallel now. So their equivalent resistance will be R, and R will again be parallel. So what will be the equivalent resistance of that circuit?
R/2.
R by 2.
স্যার এটা প্রুফ করা যাবে?
Yes, whatever I will say in that symmetry, if you try to prove that, actually I have done this proof by myself. How we can prove that? You assume the currents to be different and apply KVL. After that you will find that the currents are same. A simple formula for that. Right? So if anytime you doubt that whether it will happen or not, then at your home what you do, just take 2 or 3 loops, write down KVL KCL equation, right, in that loop, and try to solve for the currents, right? And that will be better if you solve them, right? Once you can, one thing you can practice KVL KCL, and another thing that it will you can actually verify by yourself. Okay, otherwise it's logically also it is correct, because of the symmetry circuit you cannot actually differentiate the currents. Okay, I think it is clear to all of us.
Yes, sir.
All right, moving to the next symmetricals. Next symmetrical circuit is looking like this. Here you can see that the symmetry line, if this is A and B, then you can find another type of symmetry here in this circuit about this line. Can you see about this line, the upper portion of that line and the lower portion of that line, they are nothing but mirror images.
Yes,
স্যার
sir.
এখানে ভার্টিক্যাল সিমেট্রি কেন বলছেন? মানে এটা ভার্টিক্যালি তো
It is only a name. You can remember any by any name, right? Actually, these things you will not find any book in any book, and you will not find in some other name, right? Rarely some book actually mention those, because they are actually a derived thing from KVL and KCL, right? So that is why they are not separately mentioned in any book. But again, it is only a name, right? You can say it is symmetry 1, this is symmetry 2, any type of symmetry you can use. All right, now
নোটের পয়েন্টগুলোকে কানেক্ট করতে হবে। যদি আমি এই ফিগারটাকে একদম ভার্টিক্যালি বাইসেক্ট করি তাহলে হবে না?
এটাকে ভার্টিক্যালি বাইসেক্ট করতে পারো, but that will not
লাভ
give you
হবে।
any extra equation. Can you see that if you vertically select this line, this current is definitely this current. Will it give you any other equation?
না, কোনো লাভ হচ্ছে না।
Yes. So that is why sometimes this symmetrical line also helps us. How to we can find? Look, in this symmetrical line I can say now this current is actually this current, and this current will actually be this current. As the resistance are also same and the currents are also same, can I say that the potential drops will also be same? And if the potential drops will same, can you say that this potential and this potential will also become same?
Yes, sir.
Yes or no?
Yes, sir.
Repeat this.
Yes, what I am saying, that suppose this potential is V and this current is I, this resistance is R. By symmetry, you can say that this current is also I and this resistance is definitely R given in your question. So now you can see that this potential is V, the drop is V minus IR, so the potential A will be V minus IR. Similarly, can you say that potential of B will also be V minus IR? Yes or no?
Yes.
So
Yes,
what
sir.
will be the potential of A and B? They are same. What about the
Same.
potential C and D again?
Same.
They are same. So what can I say about this type of symmetry? That the mirror points or the image points will have the same potential. In the given figure, all the sides have equal resistance R. Find equivalent resistance between AB and in between CD. চলো এটাকে সলভ করা যাক। Now look, this is a three-dimensional figure. It is given. Can you see that I can represent this entire 3D diagram in a 2D figure like this? Just try to understand what I have drawn.
Sir,
বলো।
sir, can you allow me to draw one? কেন কি আমি একটা 2D ফিগার বানিয়েছিলাম।
এক সেকেন্ড।
স্যার
তুমি এরকমও 2D ফিগার বানাতে পারো, বুঝে গেছি।
ফেলে দিলেই তো হবে।
হ্যাঁ, উপর থেকে দেখলেও হবে। ঠিক আছে, আমি বুঝতে পেরেছি। তুমি এরকম ফিগার বানিয়েছো হয়তো, উপর থেকে দেখলে এরকম ফিগার হবে দেখতে।
হ্যাঁ, একটা সিট হবে। হ্যাঁ স্যার,
এরকম ফিগার হবে। কিছু একটা বানালেই হলো, এরকমও বানাতে পারো, এরকম বানাতে পারো।
আমি ওটা বলছি না।
হ্যাঁ
স্যার, যদি সিডির পারপেন্ডিকুলার একটা প্লেন নিয়ে নিই, তাহলে তো এবি আর ইএফ এর ইয়েটা ভোল্টেজটা সেম হবে। তাহলে আমি তো এবি ইএফ টা বাদ দিতেই পারি।
বলতে পারো। তুমি যদি এই প্লেন বরাবর একটা সিমেট্রি দেখতে চাও, if you talk about
তোমায় পাশাপাশি রেক্ট্যাঙ্গেল পেয়ে যাব।
this plane you are talking about,
yes sir,
then this figure is
rectangle পেয়ে যাব।
yes, that then this figure is also symmetrical about this plane. You can also definitely you can say that, no problem. So this question can be solved in different ways. Let us try to draw it in that way. Then it is easy to understand that when I am connecting battery between A and B, when I am connecting battery in between A and B, then this is the line joining the sources. Can you see a symmetry along this line? Yes or no?
Yes sir.
So what type of symmetry it is? Vertical or horizontal? Vertical line. So yes, so along this vertical line, if I use symmetry, then which branch will carry no current?
CD branch.
CD branch will carry no current. If you just eliminate the branch CD, then the question is very much simplified. Then this resistance R and R, they are in series or parallel? These two resistors? Series. These two resistors R and R, they are also in series, right?
Yes.
Now I can simplify that circuit. This 2R, this is 2R, this is R, this is R, this is R, and there is another 2R here. Can you draw this circuit? I have just redrawn the same circuit after withdrawing the branch CD. Can you understand how I have drawn that?
Yes,
now
sir.
it is nothing but a series parallel circuit. I am very much sure you can now find the equivalent resistance. This is 2R, this is 2R, this is R, this is R, this is R, this is R. Right? So if this is 2R and this is R, then what is the equivalent of 2R and R? 2R by 3. They are in
Yes,
parallel. 2R by 3. So it is 2R by 3 plus 2R. So that is 8R by 3. 2R by 3 plus 2R. They are in series now. right? If anytime you feel that it is not clear, you can ask me. 2r by 3 plus 2r, so that is 8r by 3. So now all these three are in parallel, right? All these three are in parallel. This is 2r, this is 8r by 3, and this is r, right? So what is the equivalent circuit now? What is the equivalent resistance? 1 by 2 plus 3 by 8 plus 1. 1 divided by that will be the equivalent resistance, right? So 8 by 8 plus 3 by 8, 11 by 8 plus 4 by 8, 15 by 8. So it is 8r by 15. That should be the answer of this question. Is that clear now?
Yes, sir.
Yes.
Yes. Now again, in the similar way, in the same circuit I am talking about, same circuit, if you now apply battery voltage in between C and D, in between C and D, if you now apply battery, can you see that there is a symmetry about this line? Now this symmetry is not vertical, this symmetry is horizontal. Can you tell me why? Because now the battery is connected in between C and D, right? So if this is a horizontal symmetry, then can I say the potential between these 2 points is 0, potential drop?
Yes, sir.
So I can
Yes.
eliminate this branch, and the potential drop between these 2 points is again 0, I can eliminate this branch. So what will be the equivalent circuit? You can see the equivalent circuit is much simplified now. Can you see that? These are 3R, these are 3R. They are in parallel, so 3R by 2. With them, R is again parallel. So 3R by 2 and R in parallel means 3R by 5. Okay, this is an infinite circuit. Okay, will not solve it now. I will give you this as a homework. Right? These are infinite triangles. These are equilateral triangle. I have found another equilateral triangle by joining the midpoints. Another equilateral triangle by joining their midpoints. Another equilateral triangle by joining. So this will continue up to infinity, right? And the bigger triangle has resistance R of each of the sides, right? So you can see that the next triangle will have a resistance R by 2 of each side. Next resistance will have a R by 4 of each side. So in that
So
way,
resistance proportional to the length.
yes, it gives that in this infinite grid, all the sides are made of the same material and have uniform resistivity,
Achha.
right? And you same cross section actually. It should also be mentioned here. Same cross section. Okay. Try to solve this at home. These are infinite circuit. We have solved infinite circuit in last class. Use a similar concept. Also very simple one. Can you tell me what is the equivalent resistance between AB? Can we use this vertical symmetric circuit here? So if there is a vertical symmetry here, can I say that this current will directly go to this branch, this current will directly go to this branch, and this current will directly go to this branch?
8R by 15 असतो.
Let me calculate. Is there any importance of this node, or I can actually open this node here?
कुठे ते
So we can.
We can open this node here, right? After that, the question will be very simple. You can see that I have actually opened this node here. So its equivalent circuit will look like this. Do you agree, everyone?
Yes, sir.
Now it is simple that these are 2R with R. 2R by 3 plus 2R is 8R by 3. 8R by 3, and this is also 8R by 3, right? I'm doing Milton
4
calculation. You can also calculate it in your copy. You should find the same values. So it is 8r by 3. It is also 8r by 3 and it is 2r. So they are in parallel. 8r by 3, 8r by 3 is 2r, 4r by 3, 4r by 3 and 2r. So 1 divided by 1 by 2, 4r by 3 means 3 by 4. So 2 by 4 plus 3 by 4 means 5 by 4. So I think the answer should be 4r by 5.
Yes, sir. Okay.
Whenever you got what is the symmetry here? Can you identify what symmetry is there?
Horizontal.
Horizontal. So there lies a horizontal symmetry about this line. You can see that the above and below this line there mirror image. One thing you should understand that whenever you find a horizontal symmetry, can you actually fold this circuit? No. Can you actually fold this circuit about this line?
Yes.
Yes, because these two potentials are same, these two potentials are same, these two potentials are same. So actually I can fold that circuit about this line. If you just fold that circuit about this line, you will find this circuit will look something like this. The circuit will look something like this. Yes or no? But now the resistance will be half. This resistance will be R by 2. This resistance will be R by 2. This resistance will be R by 2. This is R. This resistance will be R by 2 and this resistance will also be R by 2. Can you understand what I have drawn here?
Parallel বলে ওগুলো
Yes.
parallel ছিল তাই জন্য
Parallel.
resistance কে
Yes,
half
if you
করে
say
দিয়েছে।
that this point is P potential, this point is also P potential. So the two resistors are there in between B and P. So they will be in parallel, yes or no? Similarly,
Yes,
if this
sir.
point is Q, this point is also Q. So two resistors are there in between Q and A. So they are also in parallel. Understood? So in that
Yes.
way, I have made all the resistance R by 2 except this one connected between A and B. Now we can calculate this R by 2 and R by 2 are in series. So they should be R and R by 2 are in parallel. R and R by 2 are in parallel. That means it will be R into R by 2 plus 3R by 2. It will be R by 3, I think. Right? So it will be R by 3 plus R by 2 plus R by 2. They are in series. So R plus R by 3 is 4R by 3. 4R by 3 and R are in again parallel. So that will be 4R by 7. I think that should be the answer of this question. Try to solve it by your own now. Check whether the answer is 4R by 7. আমি যদি এটাকে এর অ্যাবাউটে ধরো সার্কিটে শুধুমাত্র এই দুটো পয়েন্ট আছে, this is B, this is P, this is P, right? Forget about all the other resistors. So এই দুটো পয়েন্ট যদি একই পোটেনশিয়াল হয় তাহলে কি আমি বিটাকে এখানে রেখে পি দুটোকে এক জায়গায় রাখতে পারবো? আমি এই বি পয়েন্টের এই লাইনটার অ্যাবাউটে এবি লাইনের অ্যাবাউটে আমি পিটাকে ফোল্ড করে দিয়েছি। I have folded that resistor which is lower the line AB. I have folded it upward. So now these two resistance, these 2 points are having the same potential. So can I say that they will be in parallel? Now this is a cube. Each of them are having resistance R. But I have disconnected, I have removed this portion AB. Can you calculate what is the equivalent resistance between AB? Look, if I name this point is C, this point is D, this point is E, this point is F, and GH. Can you tell me which points are having the same potential?
C and E and D and F.
GH and EF. GH and EF.
Yes.
GH and EF.
GHEF.
C and D.
Yes.
E and
Look,
E.
can you see that this path AEFB and ACDB, they are symmetrical?
Yes, sir.
Yes or no? You can just find the configuration by placing the cube in another orientation. You will find the similar configuration where you will see that AEFB can take the place of ACDB. Right? So they are interchangeable. These two paths are absolutely symmetrical. So if AC and AE, they will carry now the same current as they are symmetrical. So can I say that the potential of C and E, similarly the potential of D and F, they are nothing but the same?
Sir,
Yes.
is the answer 5/4?
I don't remember actually. Let me try to solve it now.
Sir,
Yes.
স্যার এটাকে কিন্তু মানে আমি 2D তে ড্র করে আরো ইজিলি হয়ে গেল
2D তে ড্র করেও করতে পারবো, 2D তে ড্র করেও করতে পারবো. Let us first do it in this way. That suppose this point is A, right? So in between, now I can say E equal to C and F equal to D, right? So between A and C, now there are two resistors. Can you see? I have drawn this resistance as well as this resistance. And in between B and D, there are also two resistors. I have drawn this one, I have drawn this one. In between C and D, there are this resistance, I have drawn this one. In between C and D, this resistance is also there. So let us draw this resistance also. Right? Now there is another point G and H. In between G and H, there is one resistance like this. In between G and C, there are two resistance. G and H. In between G and C, there are two resistance. Like this. This one and this one. And between H and D, there are these two resistors. H and D, there are these two resistors. Now this point is B, this point is A. Is that figure simplified now?
yes sir
Now we can easily find what is the equivalent resistance. R 2R. So this will be 2R, this will be 2R, this is R. So this will be R by 2, R by 2, R by 2 and R. So this will be 2R, this is R by 2, this is R by 2, this is R by 2. Right? So R by 2 plus R by 2 is again R. And this will be R by 2 and 2R in parallel. R by 2 and 2R in parallel means what will be the equivalent resistance? R by 2 into 2R divided by 5R by 2. Right? So that is 2R by 5. So 2R by 5 plus R. So answer will be 7R by 5.
স্যার কিন্তু 2D তে ড্র করলে 33R by 23S
Excellent. 7R by 5 की ठीक calculation हलो R by 2, R by 2R, R by 2, R by 2R plus R 2R. 2R and R by 2. R plus 2R and R by 2. 2R into R by 2 by 2R plus R by 2. 2.5. 5 by 2R. 2R by 5. So 5 plus 2. I think this is the correct answer. 7R by 5. Yes, the diagram will look like this. Now the problem here is that if you say that this current is X, that current is also X. If you say this current is Y, this current is also Y. But can I say that if this current is x, this current is x, that current has to be x and that current has to be y?
না বলতে পারবো না
হ্যাঁ
That you cannot say, because that this current and this current is the same, but this current x will continuously flow like this and this current y will continuously flow like that. That you cannot say.
সো ওটা ইন্টারফেয়ার করবেই একটু
So one possibility is yes, you can say that if this is flowing like this, then this will carry no current, then there will be no potential drop. But this is only one assumption of yours. I cannot actually say from the symmetry that this current will continue like this. This one, then again, I don't think that also can be solved by symmetry in 2D, right? That also you have to solve by identifying the common potential points, right? Look here, you try to solve this question at home. No, এটা এখন করার দরকার নেই. I will give this as your homework.